Hello everybody, I am ENNOUNI Assia from the LESAC Laboratory, Faculty of Sciences, University Sidi Mohammed bin Abdellah Fez. I will present you our paper entitled Detection and Classification of Logos and Trademarks from Images, co-authored by the Professor Abdelouahed SABRI and AARAB Abdullah and me. Before starting, I would like to thank all the organizing committee of this conference. The plan of my presentation is as follows. I will begin with the introduction, then I will present you the detection and classification of logo and trademarks and present some approaches and techniques proposed in the literature. Then I will present you the proposed comparative study with the experimentation results and discussions. At the end, I will present you the conclusion and some perspectives. The study aims to conduct a comparative analysis brand logos detection approaches based on deep learning. Open logo challenge dataset was used for this purpose. The study encompasses detection and localization tasks of brand logos in images. One of the fundamental tasks in computer vision is object detection, which plays a pivotal role in different fields such as image analysis, video surveillance, autonomous robotics, and facial recognition. Object detection refers to the process of automatically identifying and locating objects of interest within images or video. The goal is not only recognize the presence of objects, but also to determine their specific location in the visual data. In recent years, logos detections have gained significant attention in the field of computer vision and pattern recognition. Numerous approaches and techniques have been proposed to tackle the challenge associated with this task, so we can define a logo as a visual symbol employed for recognition or symbolization of entities such as corporation, institution, merchandise, or brands. Logos are integral to a company's identity, and a well-known logo can positively impact a company's reputation. The process of logo recognition is outlined and involves several steps, including image processing, feature extraction, logo matching, and classification. These steps collectively contribute to identification and classification of logos within images. And logos detection approaches can be divided into two main categories, one-stage and two-stage detector. One-stage detectors directly predict the presence and location of logos in a single step. One-stage logo detectors typically leverage convolutional neural networks as their backbone architecture to extract features from the input image. Extracted features are then processed by additional convolutional layers and finally feed into a set of output layers for logo detection. Concerning the two-stage detectors, refer to two independent steps which involve region proposal generation followed by classification and localization. The first stage involved generating a set of region proposal but were likely to contain objects, and the second stage classified these proposals as either logos or background and refined their bounding boxes. Morphologic operator approach introducing in 2011 to detect logos are identified using two specifications including centroid coordinate and intersection logos bounding box. Canny and Sobel filters have been used to detect the corners of logo and to improve noises from images. Median filtering has been applied. In 2015, the authors proposed in this work depression-based convolutional networks. The proposed architecture called LogoNet was trained on two large datasets which present 110 brands. Then, author in this work presents an approach for vehicle logo detection. Features are extracted based on local patterns and the process of feature selection based on principal component analysis. The logo classification was done using a set of machine learning classifiers such as Canarus neighborhood, support vector machines, random forest, and Adabust, and collaborative representation-based classification. In 2021, author in this work proposed a cascade depth convolutional network to detect and classify vehicle logos without the need of license plots, using data augmentation to improve the logo detection and classification accuracy. In 2021, Jan and Raoul proposed the aggregated dual attention anchor-free logo detection framework based on LogoNet with adversarial domain. In our paper, we will conduct a comparative study between four deep learning architectures for logo detection and classification. We will use here RetinaNet as one-stage detectors, and for two-stage detector, we will implement the RCNN alternatives such as faster RCNN, mask RCNN, cascade mask RCNN with as backbounds respectively ResNet 50, 101, and 152. In our study, we have opted to use the database of the challenge called Open Logo Detection Challenge, which is improved version of the web logo 2M. For this task, we will use a logo image database that contains 27,083 images. For evaluation, the most commonly used measures for evaluating a logo detection are average precision and mean average precision. Average precision measures the accuracy of object detection for each individual class by comparing them to the ground truth annotation. Mean average precision provides overall performance metrics by averaging the average precision values across all objects categories. We present here the four logo detection architectures implementation results using the R50 FPN and the R101 FPN backbounds. From the results presented in this table, as you see, we can conclude that the cascade mask RCNN using ResNet 50 gives the best result. Sure, the validation loss is not better than the fast RCNN, but in terms of logo detection precision, we can conclude that the cascade mask RCNN is the best approach of the four approaches studied here for logo detection. To conclude, the study focuses on applying deep learning-based object detection algorithm for detection and localization of brand logos in images. Firstly, a comparative analysis is conducted on a popular object detection algorithms, including fast RCNN, mask RCNN, RetinaNet, and cascade mask RCNN. The study's results indicate the efficacy of deep learning algorithms, specifically highlighting the superior performance of cascade mask RCNN with the ResNet 50 as a backbone for logo detection and localization. And as a perspective, we intend to expand the dataset used in our study by incorporating additional logo images. Specifically, we aim to include logos from the Moroccan industry. And thank you for your attention.